The reason utility companies are interested in performance testing is the same reason we all are. Just because you design a home to reach certain performance and you hopefully build it along the lines of that design, the reality is we don't know for sure that it's going to perform the way we want unless we do some tests. So performance testing is intended to test the installation. Does the forced air duct system deliver the heat where you want it to go, or is it leaking into the crawl space? Does the envelope, the floor, the walls and the roof of the building hold out the cold air from outside and keep the warm air on the inside, or is it too leaky? Is it allowing too much air to move in and out? So the reason that the utilities care about that is because they provide rebates and incentives for people to take those steps. They want to know they're getting value for money. They want to know the home's actually going to perform the way it was intended to.
The class I just went to down in Dallas, this architect took a block of ice and put it in a 1-inch styrofoam picnic basket and taped sealed the top. This is in Austin, Texas, and sat it out in the hot sun under a tree and asked us, how long do you think that block of ice took to melt? His point was, air tightness is more important than the R value. A 1-inch styrofoam picnic basket is only an R3. How long do you think it took for that block of ice in the sun to melt? 2 weeks.
One of the most important things of this old home when we moved in was that it was an old house, leaky, a lot of air leaks, not very energy efficient at all. And so one of the most important things that we've done is to do a whole house energy upgrade to this remodel project. And that has included switching out all the single pane old, beautiful old windows, but not so efficient, with higher efficiency double pane windows, hyper insulating around the entire home, and then also switching out to a more efficient mechanical system. And so we looked at many different types of systems, and what we decided on was to go with a ductless heating system, a hydronic heating system.
So a super efficient boiler system.
Yes, and one of the health aspects of that is that it gets away with blowing forced air through the home. Something with having a family on the way and having a young one, we wanted to eliminate the possibility of moving a lot of air and dust, which a hydronic system is really great for.
So it cuts down on dust, dander, mold spores, just keeps the air quality high for the house.
Exactly. And so in part of that research, we were able to find Mitchell Mechanical, and then let me introduce to you Josh Mitchell of Mitchell.
Josh Mitchell, nice to meet you. Can you tell me some of the highlights for this really high efficiency boiler that you've installed here?
Yeah, well, the boiler itself actually is a combination boiler and water heater. One thing that's unique is that the water that's running through the house to heat the home doesn't actually mix with your domestic hot water. What it has is it has a 14-gallon storage tank that gives it just enough time for the boiler to start to heat through, and it actually pumps through a coil contained inside of the domestic hot water side to keep the water separate again. And then allows it to get out to the house quickly because that water was already preheated.
And you were telling me this boiler is pretty new on the market. Is this becoming a big part of your business?
Yeah, it's becoming a bigger part of our business because we don't have, the houses are smaller now and we don't have as much space to throw a bunch of mechanical equipment. So we're having to make things more compact. So combination units that don't require multiples of appliances are nice space-saving features in addition to the efficiency benefits we get out of them.
And also I just want to add that while we have one of the most stringent energy codes in the whole country here in Washington State, there are very few provisions right now to actually enforce and test in the field that Built Green homes or any new construction home or remodel is actually meeting those stringent code standards. And so one of the values of Built Green verification is that it requires performance testing of homes, that the people in the field are installing and inspecting their work as designed.
That's a very good point and a very big problem that we have, in that ductwork alone can release 30% of the energy it produces into attics and crawl spaces. And without that testing to ensure that you don't have that kind of leakage, it continues to go on. And we have no standard for that yet. So the third-party verification is extremely important in energy efficiency. And it doesn't matter how efficient your equipment is, if it's leaking, you've got problems.
Thanks, Josh.
Yeah.
Well, the first thing was keeping the envelope of the house as energy efficient as possible. So that involved the way we built the walls, the type of windows that we used, window orientation, air sealing of the house, the overall insulation level of the house. So, number one was the envelope. Number two was the heating system that we use. The ground source heat pump is the most efficient system on the market. It also provides the hot water for domestic hot water. Making sure that then all of the other appliances and lighting loads were as low as we could make them, with not just Energy Star, but trying to find the lowest energy use Energy Star appliances and fixtures that we could find. All compact fluorescent lighting. And then finally topping it off with the photovoltaics that you see in our background on the roof of the garage that supply most of the energy that the house actually does use.
So this little gray box here is the power inverter that controls the power that's being produced by the photovoltaic panels on the roof. The little LCD display in the middle is showing you what has been produced. For example, today 14.79 kilowatt hours. It shows you the type of grid is 240 volts. It has two sections that shows what they're producing. CO2 saved 4,610 pounds. 975 watts is the production at this moment at 257 volts, and the total produced to date is 2,712 kilowatt hours. So it's just over almost 15 kilowatt hours just today alone.